In this video, I want to start to look at how to find the area of an irregular shape. As an example, let's suppose we have this shape here that we want to find the area of. There's not really a good way to subdivide and recombine the region into regions whose areas are easy to determine, like triangles or rectangles. Usually, when we want to find the area of an irregular region like this, we can't determine it exactly. Instead, we have to be satisfied with getting an approximate area. A hands-on way to find the area of an irregular region like this would be to cut it out, weigh it, compare its weight to the weight of a full piece of paper, and use proportional reasoning to find the area of the region. So as an example, if I were to cut this out and it weighs 3/8 as much of a whole piece of paper, then its area is that of 3/8 as much of the area as a whole piece of paper. However, we have other ways we can do it too. One of which is by using graph paper. So I can take a piece of graph paper, and in this case, I'm going to assume that each one of these lines is 1 centimeter apart. And then we can just count the number of 1 centimeter by 1 centimeter squares inside this region and then mentally combine the remaining proportions of the region near the boundary so we can determine the actual area. If we do that, we might get an area of approximately 25 square centimeters. I can also use graph paper to find an underestimate and overestimate for the area of an irregular region. So an underestimate would be all of the complete squares. So if we were to look at this particular picture, we have a complete square here, here. This is 3, 4, 5, 6, 7, and 8 are here. 9, 10, and 11, and then 12, 13, 14 on this row, and then a final one here to give me 15. So an underestimate would be 15 square centimeters. For an overestimate, then we want to look at all the squares that have any portions. So for this, we're going to kind of outline this shape to include any squares that have any portion whatsoever of this particular irregular shape. And so we go along, and then when we're done, we can count up the number of pieces that this represents. So we get our overestimate of 42 square centimeters. So we know the area of this irregular region has to be smaller than 42 and bigger than 15. And if we use finer and finer graph paper, we get a narrower and narrower range of values that between our overestimates and underestimates. So these were all 1 centimeter, but if I were to refine them to a half or a quarter of a centimeter, or a tenth of a centimeter or something like that, the more fine we get, the better of an approximation and the smaller this range will be.